This is example 2-8, where we're going to find what the force is and the location of the force resulting from the pressure on that little window here inside of this pool of water. Right? So we're given that's water, so we know what the density or the specific gravity are. And so now what we have to do is we have to find where the force is acting and what the force is, and we're supposed to use the formula method. Right? So remember, for our formula methods, we know that, maybe I'll write that down here real quick, right? That F R is going to be gamma times H bar times A. So the first thing we have to do is we have to find what the depth is at the centroid of that window, right? The centroid of our window is going to be somewhere here because it has to be 1/3 down from the top, right? So that's what we can say. So we can say our H bar, right, is going to be, well, we're not given what the top is, we're given what the bottom is, right? So we can say that'd be 5 meters, right? It would be down here. So that still means we have to go 2/3 up. So that'd be minus 2/3 times 1.8 meters, right? 2/3 of 1.1 third of 1.8 is 0.6, so that'd be 1.2 meters. So 5 minus 1.2 is, of course, 3.8 meters. So with that, we can plug that into our formula. Right? Fr is equal to gamma times H bar times A. Gamma is 9,810 Newton per cubic meter for water, times 3.8 meters, and then our area, sorry, I have to kind of squish this in here, is 1/2 times the base is 1 + 1, 2 meters, and the height is 1.8 meters. And then if we plug that numbers in, we get 67,100.4 Newton. Right? It's because we had the Newton here, meter cubed, meter, meter, meter. So that all works out. So that would be 67.1 kilonewton, pretty much exactly on the head. All right, and then to find our location, right, we say that P is equal to Y bar plus Ix bar over Y bar times A. Most of these things are easy to find. The more complicated one is, of course, the moment of inertia, so we'll start that first. Ix bar. In our case, we have a triangle, and we're going along the center line, so that's easy. So we have just B times H cubed over 36. So in our case, the base is 2 meters. The height is 1.8 meters. Third power divided by 36. And that turns out to be 0.324 exactly. And of course, meters to the 4th power. That means we can plug now the value in, Yp. We already know what, in this case, the depth is the same as how far down at the center it is. So that'd be 3.8 meters. Now let's write the equation in first. Let's erase that and say Y bar plus Ix bar over Y bar times A. Plug those numbers in, 3.8 meters plus 0.324 meters to the 4th power divided by 3.8 meters, right, or Y bar, and then again our, not plus, but times. All right, and then our area is just 1/2 times the base, which was 2 meters, times the height, which was 1.8 meters. And plugging that in, we get 3.8474 meters, or 3.85 meters if we round to 3 significant digits. Right, so that would be, we now know that the pressure, the overall force acting on that window based on the pressure, is 67.1 kilonewton, and we know that it is 3.85 meters down. So just a little bit past where we said where the centroid of the glass is, for 5 centimeters down from that. So that all makes sense.